Section 8.2 talks about testing a claim about a proportion, identical to kind of what we did on 8.1, but now you're doing the testing over not a mean, a proportion. Hypothesis testing, well, claim about a proportion requirements. 1. The sample observations are a simple random sample. 2. The conditions for binomial distribution are satisfied. 3. If NP is bigger than or equal to 0 and, not or, and NQ are bigger than 0, then the normal distribution can be used to approximate. Then the normal distribution can be used to approximate the distribution of the sample proportion with the mean equal NP, and the standard deviation is the square root of NPQ, which is the binomial distribution average and standard deviation. So steps for hypothesis testing when applied to testing proportion, it's identical. It is a valid simple random sample. Hypothesis testing, if the alternative hypothesis is equal, then you would say P is either less than P naught, or P is greater than P naught, or P doesn't equal P naught. And just like before, we use alpha normally 5% if not given or specified. Now, the test statistics is fairly simple. The test statistics method, Z equal, we take the proportion minus the calculated divided by the square root of P sub 0, Q sub 0 over N, and that's no big secret. That's what we will be using. Forget that part and forget that part. So it has to be to find a Z. Find the critical value or the p-value. We're going to do both on every example. I'm going to make sure that you get that. Make a conclusion. Make a decision and draw a conclusion. Either reject the null hypothesis or fail to reject the null hypothesis. So again, everything is based on the null hypothesis. Well, if we are dealing with one-sided or two-sided, that will make a difference. If we're dealing with one-sided, then the alternative should find that, or testing, whether it is less than. So whatever you did, whatever example you're looking at, the proportion seems to be less than what they're claiming. The claim is that it's always the same. Remember, the null hypothesis says, oh, nothing changed, always. If you find that in the sample, the actual proportion is greater than, then it's a right tail. Less than, it's a left tail. And if you're testing if it's anything other than, then this is where you really have to talk about two-sided test, and that makes a big difference as far as the p-value and the test statistics, because then you're going to split the alpha into those two regions instead of having alpha on one end. So the critical values, if this is the rejection region. So let's go this way actually. If my test statistics fall in there, I would reject the null hypothesis. And if my test statistics fall in there, I will fail to reject the null hypothesis. Same deal here. If I fall into either of those two regions, if my test statistics fall in there, I will reject the null hypothesis. And if my test statistics fall anywhere in between there, then I will fail to reject the null hypothesis. And the same deal, this is the rejection region. If my test statistics fall in there, I will reject the null hypothesis. And if my test statistics fall anywhere in there, I would fail to reject null hypothesis. Now remember, if I'm doing the p-value, if the probability is less than 5%, we reject the null hypothesis. Because we say you can't say it's the same if it's only happening less than 5% of the time, which is unusual. Unless they specify something different than 0.05. And here's the first example. So we have 3 examples to go over. According to the Census Bureau, 8.8% of the U.S. population had no health insurance coverage in 2017. Suppose that in a recent random sample of 1,200, 130 had no health insurance. So p hat is actually 130 divided by 1,200. I'll figure out what that is in a minute. And here they changed the alpha 0.02 significance level to test the claim. And here's the null hypothesis. Here's the alternative hypothesis. Test the claim that the current percentage of Americans who have no health insurance is greater than. Since it's greater than 8.8%. So it's important to see where the claim is. During our test, either we're going to accept or we're going to reject the null hypothesis. Remember, the null says, oh, you know what? It didn't change. It's still 8.8%. Well, based on the sample of 1,200, do you agree or disagree? And let's see how this plays. We're supposed to use either a p-value or a test statistics. I'm going to use both on each problem. So, if I want to go by the test statistics method, I'm going to use z equal p hat minus p naught divided by the square root of p sub 0 q sub 0 over n. And hopefully you remember how those go. This is, I need to know where that is. 1,200 divided by 130. 130 divided by 1,200. You know, same thing, right? Just kidding. So that's 0.1083. So according to the sample, 10.83%. And that's why they're claiming it's higher. So this is going to be 0.1003 minus, and h naught, and again, that's why we're always rejecting or failing to reject. The null hypothesis says no, it is 8%. 8.8%. Square root of 8%, and 1 minus 8.8% is 9.12% divided by n, which is 1,200. And if I throw this in my calculator, I'm looking at parentheses 0.1083 minus 0.088 divided by square root of 0.088 times 0.912 divided by 1,200. And let's see how that looks. That looks pretty good. 2 point, and let me copy that down. So I'm getting that to be 2.48. So it's very important to get that for 2. So now what? Now I have 2 options. Should I do the p-value? Let's do the p-value in green. The probability that z is greater than 2.482. Just making sure I inputted everything correctly. Yeah. is going to be, and how do I do that? Well, here we are. They gave us one graphic because they thought we were going to do only one. What's the area to the right of 2.482? And I'll get my calculator out and I'll go for a distribution, and I want a normal CDF, and the area is going to run from, what did we say? I forgot. 2.482. The upper is, remember we put 1 e to the 99. The average in this case would be using a z-score. This is what we're getting. So notice if we use the probability, we're getting the answer to be, the probability is 0.7%. That's less than 1%. So automatically we reject the null hypothesis. You can't say things happen due to chance if they only happen less than 1%. Now let's go with the blue and use a critical region. What we do, we got a value. We got a 2.46482. What we have to do, we have to figure out the rejection region. Since we're looking at a one-sided, and this is 0.02, and I'm getting that because they told me that. So to figure out what this number is, and this is the rejection region, this is the region you don't want to be in. So if this number falls in there, I reject the null hypothesis. If it falls in there, I would fail to reject. And I need you to know both. So if I take my calculator, oops, wrong calculator, my mistake. If I go for my inverse normal distribution, I'm looking for an area of 0.02, and it's a right tail. Whoops. And it's telling me the cutoff. The cutoff is 2.05. 2.05. This is the cutoff. Remember, this is 0. So I take this number and I notice that that number is to the right. So it falls in the rejection region. So because of that, I reject the null hypothesis. Conclusion. If I reject the null hypothesis, now that's why it's important to say where the claim is. So I'm rejecting this. So this sample seems to support the claim, which is the proportion is bigger than 8.8%. So there is sufficient sample. So basically you're basing this on the sample evidence for this sample to support the claim and this is not a big secret. You're just gonna reiterate what they said. Significant test the claim that the current percentage of Americans who have no health insurance is greater than 8.8. Pretty much exactly as you see it. To support the claim, the true proportion of U.S. population with no health insurance coverage is greater than 8.8% or 0.0. Now this is just for practice. Identify the type 1 error. I remember the type 1 error because I always remember that type 1 error, you reject the null hypothesis. And how would you be at an error? Well, you reject the null hypothesis when, if you are mistaken, when it was true. What does that mean? That means we say, if you reject the null hypothesis, we say that people without health insurance is greater than 8.8% of the US population, when it's actually not. Type 2 error, I remember type 2 error by fail to reject H naught. But it is false. So here you would say that people without health insurance is 8.8%. Kind of like the problem we just did. The error would be fail to reject the null hypothesis. Here we rejected it. Of the US population, when in reality it is more.